And now in this lecture we'll find out the area of a circle. In the drawing we have a circle. This is called AB. This is equals to 8 units in its length. This is called PQ. This is equals to 6 units in its length. This is angle PMQ. This is the right angle. And we have also here angle B, peripheral angle BAQ. And this is peripheral angle MPQ. Again, our task is to find out the area of this circle. So first of all, we'll focus on this arc BQ. The red line PQ is defined as arc BQ, and here this is peripheral angle ABQ that subtends on arc BQ. This is peripheral angle PMQ. This is peripheral angle PBQ that is also subtend on arc BQ. So those two angles, they are both subtend on the same arc BQ, and therefore they are equal to each other according to rule 29. Okay, rule 29. According to rule 29, peripheral angles that subtend on the same arc are equal to each other. This is peripheral angle BDC, and this is peripheral angle BEC. They are both subtend on the same arc BC, and therefore they are equal to each other. That is to say, angle BDC is equals to alpha is equal to peripheral angle BEC is equals to beta, or alpha equals to beta. So those two peripheral angles, they are both subtend on the same arc BC, and therefore they are equal to each other. That is to say, alpha equals to beta. So we can actually implement rule 29 in our drawing. Why? Because in our drawing we have this is peripheral angle BAQ, it's subtend on arc BQ, and this is peripheral angle QPB, this is also subtend on the same arc BQ. And therefore, those two angles, they are equal to each other according to rule 29. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha, because they are equal to each other according to rule 29. So in the next step, we will focus on this arc AP. This is arc AP, and from the drawing it is very easy to see that this is peripheral angle AQP that subtend on arc AP again. This is peripheral angle AQP that subtend on arc AP, and this is peripheral angle ABP is also subtend on the same arc AP. So those two peripheral angles, they are both subtend on the same arc AP, and therefore they are equal to each other. So if we define the size of this angle as beta, then the size of this angle must be also equal to beta, because they are equal to each other according to rule 29. Those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. But this is angle PMQ, that is the right angle, and therefore this angle must be also equal to 90 degrees in its size. according to the rule that vertex angles are equal to each other. So in this right triangle A and B, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in the right triangle ABM? We have alpha plus beta plus 90 degrees. In total, they must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle A and B, alpha plus beta plus 90 degrees. In total, they must be equal to 180 degrees. Here you subtract 90 degrees from this equation, you get that alpha plus beta equals to 90 degrees. Here we multiply this equation by 2 and get that 2 alpha plus 2 beta equals to 180 degrees. According to equation 1, we can find out that 2 alpha plus 2 beta equals to 180 degrees. In the next step, we define the center of this circle. This point is point O. And what is a central angle? A central angle is an angle in a circle with its vertex is at the center of the circle, and its two sides are two radii of the circle, and the two sides forming an arc. So, repeat again, a central angle is an angle in a circle whose vertex is at the center of the circle, and it has also two sides. It has two sides that are two radii, and together they are forming an arc on the circle's circumference. So here we draw triangle POA. Triangle POA starts from the center of the circle, so its vertex is in the center of the circle, that is to say point O. And we join points O and A together by a line. So here actually created triangle AOP, and we have we can implement here rule 13. I'll repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing, you have a circle. This is peripheral angle ACB, is equal to theta. Peripheral angle ACB subtend on RKB. Again, peripheral angle ACB subtend on RKB or chord AB. And therefore, according to this rule 13, central angle AOB that is subtended on the same arc RKB will be twice as large as this peripheral angle ACB. Peripheral angle ACB equals to theta, therefore central angle AOB must be equal to 2 theta. So we can implement rule 13 in our drawing. Why? Because in our drawing we have this is peripherical AQP. Peripherical AQP subtend on RKP. Again, peripherical AQP subtend on RKP. And according to Rule 13, the third triangle AOP, that is also subtend on RAP, must be twice as large as peripherical AQP. Peripherical angle AQP equals to beta, and therefore third triangle AOP must be equal to 2 beta, according to Rule 13. Likewise, we create another third triangle by joining points O and B together by O and Q together by straight line. And we join also points O and B together by straight line. By doing this construction, we create the third triangle BOQ. Third triangle BOQ, third triangle BOQ subtend on chord BQ. Again, third triangle BOQ subtend on chord BQ. This is peripherical BPQ, that is also subtend on chord BQ, and it is equal to alpha degrees in its size. Therefore, the third triangle BOQ, that is subtend on the same chord BQ, must be equal to 2 alpha. In the next step, we define angle QOP, this angle SX, and we define angle AOB, this angle SY. We know that the sum of the angles around any point is equal to 360 degrees. Again, the sum of the angles around any point is equal to 360 degrees. Again, the sum of the angles around any point is equal to 360 degrees. So the sum of the angles around point O must be equal to 360 degrees. So which angles we have around point O? So if we focus on point O, the sum of the angles around point O must be equal to 360 degrees. So which angles we have around point O? We have, this is angle 2 alpha, this is angle 2 beta, so 2 alpha plus 2 beta plus x plus y, in total they must be equal to 360 degrees, according to the rule that the sum of the angles around any point is equal to 360 degrees. Then again, the sum of the angles around point O must be equal to 360 degrees. So which angles we have around point O? We have one angle is 2 alpha, the other angle is 2 beta, and we have angle x and angle y. So in total, 2 alpha plus 2 beta plus x plus y must be equal to 360 degrees. We already found out that 2 alpha plus 2 beta equals to 180 degrees. Therefore, we substitute 2 alpha plus 2 beta in this equation by 180 degrees. So we have 180 degrees plus x plus y equals to 360 degrees. Here we subtract 180 degrees from this equation, and we get that x plus y equals to 360 degrees plus 180 degrees is 180 degrees. So x plus y equals to 180 degrees. This will be equation 2. X plus y equals to 180 degrees. So here I can implement Rule 30 in our drawing. According to Rule 30, certain angles that subtend on equal arc, certain angles that subtend on equal chords are equal to each other. So in the drawing you are thinking, this is the triangle COD, this is equals to alpha, this is angle AOB, this is equals to beta, And we know that chord CD equals to chord AB. And because of the fact that those two peripheral angles subtend on equal chords, that is to say chord CD equals to chord AB, they must be equal to each other in their sizes. That is to say alpha equals to beta. Again, if chord CD is equal to chord AB, then those two center angles must be equal to each other in their sizes. That is to say alpha equals to beta. Okay, so in the next step, I will draw a circle with a center angle Y, and we have here a center angle X that subtend on chord QP that equals to 6 units in its length. So we create here chord, new chord that is also equals to 6 units in its length, and therefore the new center angle will be also must be also equal to X, because of the fact that center angle QOP equals to X, and it subtend on chord PQ that is equal to 6 units in its length. So if we create another center angle with a chord that is equal to 6 units in its length, it must be also equal to X units in its size according to rule 30. Why? Because center angles that subtend on equal arcs must be equal to each other in their sizes. So if we create a center angle that is also subtend on arc that is equal to 6 units in its length, then it must be equal to this center angle QOB that is equal to X. So first of all, I will draw angle Y in the new circle. And angle Y has two sides, OA and OB. Or the legs of angle Y are OA and OB. So actually, this is angle, center angle Y, that the copied from the original drawing. Center angle Y subtend on chord AB. So from this point B, we draw chord that equals to 6 units in its length. Again, from this point B, we draw chord that equals to 6 units in its length. And we define this point as point C. We join points O and C together by straight line. So we created in this construction, we created chord BC that is equal to 6 units in its length according to our construction. Again, chord BC equals to 6 units in its length according to our construction. And according to rule 30, if two certain angles uh, center angles that subtend on equal chords are equal to each other. This is a center angle QOP that subtend on chord PQ that is equal to 6 units in its length, and the size of center angle QOP is X. Therefore, according to rule 30, this is center angle BOC that is also subtend on chord BC that is equal to 6 units in its length, and therefore it must be also equal to X units in its size, according to rule 30, that center angles that subtend on equal chords are equal to each other. Center angle QOP subtend on chord QP that is equal to 6 units in its length, and therefore center angle BOC that is also subtend on chord that is equal to 6 units in its length. So those two center angles are both subtend on the same chord that is equal to 6 units in its length, and therefore they must be equal to each other in their sizes. So if the size of this angle is X, then the size of this angle must be also equal to X, because they subtend on a chord that is equal to 6 units in its length. So this center angle must be also equal to X units in its length. We have already found out that X plus Y equals to 180 degrees. Moving to equation 2, X plus Y equals to 180 degrees. So the big angle AOC, this is the big angle AOC, that is equal to 180 degrees in its size, and we know that any angle that is equal to 180 degrees in its size, it is defined as a straight line. Therefore, angle AOC is a straight line, and therefore AC is a straight line. AC is a straight line because angle AOC equals to 180 degrees in its size. So AC is a straight line, but AC is a straight line that touches the circle at 2 points, A and C. Therefore, AC is a chord. AC is a chord that passes through point O, that is the center of the circle. AC is a chord that passes through point O, that is the center of the circle. And you know that any chord that passes through the center of the circle, it is defined as a diameter. Therefore, chord AC is the diameter of the circle. So it is known, if we found out that chord AC is the diameter of this circle. So in the drawing, you have peripheral angle ABC that subtend on chord AC, that is the diameter of the circle. Again, this is peripheral angle ABC that subtend on chord AC, that is the diameter of the circle. So here we can implement rule 7. Repeat quickly rule 7. According to rule 7, if a peripheral angle subtend on the diameter of the circle, then it is equal to 90 degrees in its size. So in the drawing we have a circle. This is peripheral angle ACB, and we know that peripheral angle ACB subtend on AB, that is the diameter of the circle, and therefore peripheral angle ACB is equal to 90 degrees in its size. So we can implement rule 7 in our drawing. In our drawing, we have peripheral angle ABC that is subtend on chord AC, that is the diameter of the circle, and therefore peripheral angle ABC must be equal to 90 degrees in its size according to rule 7. So angle ABC equals to 90 degrees in its size according to rule 7. In the next step, we'll implement the Pythagoras theorem on the right triangle, triangle ABC. According to what is given in the question, side AB equals to 8 units in its length. According to our construction, side BC equals to 6 units in its length. AO is the diameter of the circle, that is the missing side. So we'll implement the Pythagoras theorem on this right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, here by PT is the equation for Pythagoras theorem. So in the right triangle ABC, AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. And again, according to the Pythagoras theorem, in the right triangle ABC, AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC squared equals to AB squared plus BC squared. AC is the missing side, so we leave it as it is, so it is AC squared equals to AB squared. AB is 8, therefore AB squared is 8 squared, that is 64, plus BC squared. BC squared. BC is 6, therefore BC squared is 6 squared, that is 36. So in total, we found out that AC squared equals to 64 plus 36. 64 plus 36 is 100. So AC squared equals to 100. Here we take out of this equation and find again that the missing side AC equals to the square root of 100, it is 10. So AC equals to 10. AC is the diameter of the circle, that is equal to 10. And therefore the radius is AC over 2, that is 10 over 2, that is 5. So we found out that the radius R of this circle is equal to 5. Our task is to find out the area of this circle. So we know that the area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared, that is r squared. So it is pi times r squared. R is 5, therefore r squared is 5 squared, that is 25. So in total we found out that the area that we are looking for this question, that is the area of this circle, equals to either 25 pi square units in its size, or in terms of numbers, it is equals to 78.54 square units in its size. And that is the answer of the question. I repeat again, we found out that the area of this circle is equal to either 25 pi square units in its size, or in terms of numbers, the area of this circle equals to 78.54 square units in its size. So in the next step, I'll start the lecture. In this lecture, our task is to find out the area of this circle. So in the drawing we have a circle. This is called AB. This is equals to 8 units in its length. This is called PQ. This is equals to 6 units in its length. This is angle PM. Angle PMQ. That is the right angle. Again, our task is to find out the area of this circle. So first of all, we implemented all 29 in our drawing. according to Rule 25, peripheral angles that subset of the same arc are equal to each other. So in the drawing we have a circle. This is peripheral angle BDC that subset on arc BC. This is peripheral angle BEC that subset on the same arc BC. And therefore, because of the fact that those two peripheral angles subset on the same arc, they must be equal to each other at their sizes. This is to say alpha equals to beta. So we can actually implement Rule 29 in our drawing. Why? Because in our drawing, if you focus on this chord arc BQ, this is peripheral angle BAQ that subset on arc BQ, and this is peripheral angle BPQ that is also subset on the same arc BQ. And according to Rule 29, because of the fact that those two peripheral angles subset on the same arc BQ, they must be equal to each other and their sizes. So if the size of this peripheral angle is alpha, then the size of this peripheral angle must be also equal to alpha, because they are equal to each other according to Rule 29. Likewise, if you focus on this arc AP, we have here peripheral angle PQA that subset on arc AP, and we have also peripheral angle ABP that is also subset on the same arc AP. So those two peripheral angles subset on the same arc AP, therefore they must be equal to each other in their sizes according to Rule 29. So if the size of this angle is beta, then the size of this angle must be also equal to beta, because they are equal to each other. In the next step, explain to you what is a central angle. A central angle is an angle in a circle whose vertex is at the center. The vertex of the central angle is here at the center, and it has two sides that are the radii of the circle. For example, angle AOB is defined, angle AOP is defined as central angle because the vertex of angle AOP is here at point O, that is the center of the circle, and angle AOP consists of side OA, this is the radius of the circle, and side OP, this is also the radius of the circle. And the two radii forming together arc AP. Again, the two radii of central angle AOP, they are forming arc AP. Okay, so this is this is central angle AOP that subset on arc AP. So here we can implement Rule 13. Repeat quickly Rule 13. According to Rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. On the same chord or the same arc, doesn't matter. So in the drawing we have a circle. This is peripheral angle ACB that subtends on chord AB, and it is equal to theta in its size. So according to this Rule 13, the central angle AOB that is also subtended on the same chord AB must be twice as large as the peripheral angle ACB. Peripheral angle ACB equals to theta, therefore the central angle AOB must be equal to 2 theta. So we can actually implement Rule 13 in our drawing. Because in our drawing we have peripheral angle AQP that subset on chord AP, and it is equal to beta, and therefore the central angle AOP, it is also subset on the same arc I, that is also subtended on the same arc AP, must be equal to 2 beta. Likewise, we have peripheral BAQ, that is subtended on chord B on arc BQ, and it is equal to alpha. And the fourth triangle BOQ, it is subtended on the same arc BQ, must be equal to 2 alpha. Okay. In the next step, we define this is angle AOB SY, and we define this angle POQ SX. And those two angles are defined as vertex angles, so we know that vertex angles are equal to each other. But this angle equals to 90 degrees, and therefore this angle must be also equal to 90 degrees in size because they are equal to each other. So actually we have here two right angles, and we know that the sum of the angles in the triangle is equal to 180 degrees. So if we focus on this right triangle A, triangle AOB, or triangle, the sum of the angles in this triangle AOB must be equal to 180 degrees. So alpha plus beta, actually I'm talking about the right angle. So if you focus on this right triangle A and B, this angle equals to 90 degrees, and therefore triangle A and B is the right angle. In this triangle A and B, alpha plus beta plus 90 degrees equals to 180 degrees. Repeat again. In the right triangle A and B, alpha plus beta plus 90 degrees equals to 180 degrees, according to the rule that the sum of the angles in the triangle is equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we found out that alpha plus beta equals to 180 degrees minus 90 degrees is 90 degrees. So alpha plus beta equals to 90 degrees. Here we multiply this equation by 2, and we found out that 2 alpha plus 2 beta equals to 180 degrees. So according to equation 1, 2 alpha plus 2 beta equals to 180 degrees. We know that the sum of the angles around any point is equal to 360 degrees. Again, the sum of the angles around any point is equal to 360 degrees. So the sum of the angles around this point A, must be equal to 360 degrees. So which angles we have around point A? We have 2 alpha plus 2 beta plus x plus y. In total, they must be equal to 360 degrees. So if we focus on point O, the sum of the angles around point O must be equal to 360 degrees. So which angles we have around point O? We have 2 alpha plus 2 beta plus x plus y. In total, they must be equal to 360 degrees. But we only found out that according to equation 1, 2 alpha plus 2 beta equals to 180 degrees. So we can substitute 2 alpha plus 2 beta here, this equation, by 180 degrees, and get that 2 alpha plus 2 beta is 180 degrees plus x plus y equals to 360 degrees. Here we subtracted 180 degrees from this equation, and we found out that x plus y equals to 360 degrees minus 180 degrees is 180 degrees. So according to equation 2, x plus y equals to 180 degrees. In the next step, I presented to you rule 30, and we implemented rule 30 in our drawing. According to rule 30, central angles that subtend on the same chord are equal to each other. In the drawing we have a circle, and here this is central angle COD, this is central angle AOB. If we know that chord CD is equal to chord AB, then those two peripheral angles must be also equal to each other in their sizes. That is to say, alpha equals to beta. Again, if we know that chord CD is equal to chord AB, that is to say, those two central angles subtend on equal arcs, then they are equal to each other in their sizes. That is to say, angle alpha equals to angle beta. Okay, again, according to rule 30, central angles that subtend on equal chords are equal to each other in their sizes. So if chord CD equals to chord AB, then they must be equal to each other in their sizes. This is to say, angle alpha equals to angle beta. We implemented all 30 in our drawing. So in our drawing, we have, this is center angle AOB, so I copy this center angle AOB in your page. Center angle AOB equals to y degrees in size. This is center angle AOB, that is according to the original drawing. It is given as a equation that called AB equals to 8 units in its size, in its length. In the next step, I copied actually from point B. From point B, I draw a chord in such a way that the length of chord BC will be equal to 6 units in its length, and we join points O and C together by a straight line. By doing this construction, we can do center angle POC that subtend on chord BC that is equals to 6 units in its length. Again, by doing this construction, we can center angle BOC that subtend on chord BC that is equals to 6 units in its length according to our construction. And because of the fact that center angle POQ is subtend on chord PQ that is also equals to 6 units in its length, and according to rule 30, we have according to rule 30 in front, according to rule 30, center angles that subtend on equal arcs are equal to each other. So this is center angle BOC that subtend on chord BC that is equals to 6 units in its length. This is center angle POQ that subtend on chord PQ that is also equals to 6 units in its length. And according to rule 30, they must be equal to each other in their sizes. So the size of center angle POQ is x, and therefore the size of this center angle COB must be also equal to x, because they are both subtend on arc on chord that is equal to 6 units in its length. So the size of center angle COB must be also equal to x degrees in its size, because it's subtend on arc BC that equals to 6 units in its length, exactly like this center angle POQ that is also subtend on arc that is equal to 6 units in its length. The size of this center angle POQ is x, therefore the size of this center angle COB must be also equal to x degrees in its size. So actually found out that the big angle AOC equals in total to x plus y. But we already found out that x plus y equals to 180 degrees in its size. So the big angle AOC must be a straight line, because any angle that is equal to 180 degrees in its size, it is defined as a straight line. AOC is a straight line, therefore AC is a straight line. Again, because of the fact that angle AOC is equal to 180 degrees in its size, AC is defined as a straight line. So AC is a straight line, but AC is a straight line that touches the circle at 2 points, A and C. Therefore AC is a chord, because it touches the circle at 2 points A and C. AC is a chord that passes from point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord AC that passes from point O, that is the center of the circle, is the diameter of the circle. So AC, the diameter of the circle. So we have here triangle ABC, and we have peripheral angle ABC. Peripheral angle ABC subtend on AC, that is the diameter of the circle, and therefore, according to rule 7, peripheral angle ABC must be equal to 90 degrees in its size. Repeat quickly on rule 7. According to rule 7, if a peripheral angle subtend on the diameter of the circle, it is equal to 90 degrees in its size. So in the drawing, we have a circle, and this is peripheral angle ACB, that is subtend on AB, that is the diameter of the circle, and therefore, according So this rule 7, peripheral angle ACB must be equal to 90 degrees in size. So we can actually implement rule 7 in our drawing. Why? Because in our drawing we have peripheral angle ABC that is subtended on AC, that is the diameter of the circle, and therefore according to rule 7, peripheral angle ABC must be equal to 90 degrees in size. So this is again ABC, this is equal to 90 degrees in size according to rule 7. So in the next step, we implemented the Pythagoras theorem on this right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle ABC, according to the Pythagoras theorem, AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. So in the right triangle ABC, here by PT is the equation for Pythagoras theorem. AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC is the missing side, so we leave it as it is, so it is AC squared, and it is equals to AB squared. AB is 8, therefore AB squared is 8 squared, that is 64, plus BC squared. BC is 6, therefore BC squared is 6 squared, that is 36. So in total, we should find out that AC squared equals to 64 plus 36. 64 plus 36 is 100, so AC squared equals to 100. Here we took a root out of this equation, and found out that AC equals to the square root of 100. AC squared equals to the square root of 100, that is 10. So AC, the diameter AC equals to 10 units in itself. If the diameter is 10, then the radius must be equal to 10 over 2, that is 5. So we found out that the radius of this circle R equals to 5 units in its length. Our test is to find out the area of this circle. Actually, we know that the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is also, the area of our circle must be equal to pi r squared. But r is 5. R is 5, therefore r squared is 5 squared, that is 25. So in total, we found out that the area of this circle, that is the area that we are looking for in this question, or the area of this circle, it is the same circle, it is equal to either 25 pi square units in its size, or in terms of numbers, the area of this circle equals to 78.54 square units in its size. Okay, thank you very much.